Hello, Miss Howington here. In this video, we are going to talk about the atmosphere of Earth, as well as a little bit of the start of climate. So, to start with, the atmosphere is a thin layer of gases that surrounds the Earth. It's made up of lots of different layers. Let's talk about those layers. So, the layer that we live in is called the troposphere, and it contains 75 to 80% of the mass of the entire atmosphere. So that means that the air pressure is highest here. So we have the most air particles in the troposphere. So those air particles are kind of piled on top of each other to make higher pressure here. And so the air particles are closer together, which kind of helps us breathe and that kind of stuff. The troposphere ranges from a level, which is 0 kilometers above Earth, to 17 kilometers above Earth, or, since we live in the good old US of A, that's 11 miles. As you go up in altitude, temperature decreases. That's because Earth is acting as a heat source, and so once the incoming radiation from the sun has been absorbed by the surface of the Earth, Earth then re-radiates some of that back up into the atmosphere. And so as you get farther away from the heat source, it gets cooler. So it's kind of like if you have a stove with the eye on and you put your hand right above the eye, it's really super hot. But as you move your hand up above that eye, it gets a lot cooler. So as we go up in altitude, we get to the tropopause, when there are layers, the layers that are in between the actual atmospheric layers, we call them pauses. So the tropopause is in between the troposphere and the stratosphere. So the stratosphere goes from about 17 to 48 kilometers, more or less, or, U.S. measurements, 11 to 30 miles. And so the thickness of these layers doesn't stay the same all the time. It varies with the seasons, and it varies with the latitude, so how far away you are from the equator. The stratosphere has much more ozone than the troposphere. The stratosphere actually contains the ozone layer. The ozone layer is about from 17 kilometers above sea level to 30 kilometers above sea level, or in U.S. measurements, 11 to 19 miles. And the stratospheric ozone layer is super important because it absorbs UV energy. So we can take a look here at this illustration of how that works. So as UV energy comes in, it splits apart one of the oxygens from the ozone, and then those free oxygens can go form O2 molecules, and then the radiation can split them and cause the reformation of ozone as well. So since that energy is being kind of used up in that chemical reaction, it doesn't make its way down to Earth, and that's pretty good because UV radiation can be pretty harmful to plants and animals on Earth. It can cause some DNA mutation. In the stratosphere, the temperature increases as altitude increases. Because the ozone layer is absorbing so much of that incoming solar radiation, it increases the temperature of the stratosphere as you go up in altitude. And then we go to the stratopause and then the mesosphere. In the mesosphere, ranges from 50 kilometers and then it ends at about 80, or maybe a little bit more depending on the season, kilometers above sea level. And again, that's about 30 to 53 miles above sea level. And here in the mesosphere, the temperature decreases as altitude increases, because in this layer of the atmosphere, there's a greater radiative loss of heat than there is solar gain. This layer tends to get thinner in the summer and thicker in the cooler months. The mesopause, which comes on top of the mesosphere is known as the coldest part of Earth's atmosphere. So then we get to the thermosphere. This is about 85 kilometers above sea level to 500 kilometers above sea level, and again, depending on the season and the latitude, it varies in thickness, and in miles, that's 53 to 310 miles above sea level. And so here the temperature is increasing as altitude increases because because this layer of the atmosphere is receiving a lot of solar energy. And so the higher up you go, the more solar energy you're receiving. And then you get to the exosphere, and then the exosphere leads out on into space. So the troposphere and the stratosphere are the two layers that we are most concerned with in studying environmental science, because the troposphere, this is a layer that's super important to us because it's where we live, number one. It's where weather occurs and climate occurs. So all the processes in the troposphere pretty much influence life on Earth and help determine what kind of life can live where. And then the stratosphere and the ozone layer, that's super important because that helps allow life on Earth. The air in the troposphere is composed of 78% nitrogen gas, or N2 gas, 21% oxygen, or O2 gas, and then the other 1% or so of the troposphere is made up of water vapor, argon, carbon dioxide, and some other trace gases. And those other gases, even though they're in such small amounts, they can play big roles in influencing the atmosphere. All right, so let's move on to climate. So climate is defined as an area's general pattern of atmospheric condition for over long periods of time. That's at least 3 decades ranging to thousands of years. Another way of defining climate is an area's average weather. So to understand that, we need to know what weather is. So weather is the physical conditions in the lower atmosphere that can include temperature, precipitation, humidity, wind speed, cloud cover, and lots of other variables. Climate varies all over Earth due to several things. First thing is the uneven heating of the Earth's surface, which kind of drives these other two things. So different areas of Earth get different amounts of sunlight, so the equator usually gets the most sunlight, and then as you move away from the equator, you get less and less sunlight, and that changes with seasons as well, because during winter in the northern hemisphere and in the southern hemisphere, the Earth is tilted away from the sun, so that allows the southern hemisphere to get more direct sunlight, and the northern hemisphere gets less direct sunlight. And then in the summertime in the northern hemisphere and wintertime in the southern hemisphere, the axis of the Earth is pointed towards the sun. So that means that more direct sunlight is coming to the northern hemisphere and less direct sunlight is hitting the southern hemisphere. So that uneven heating of Earth's surface creates patterns of global air circulation, which there will be a whole video devoted to. So just wait for that. And then also ocean currents can help determine climate. If a warm ocean current is flowing near an area, then that area's climate tends to be a little bit warmer and moister. If a cold ocean current is flowing by an area, then that area tends to be a little bit cooler and drier. Some other things that influence climate are landforms, such as mountains. So mountains can create a rain shadow effect. So if a prevailing wind brings a rainstorm in and it hits a mountain, those clouds are forced up, but they're going to drop all of their rain because as we go up, air pressure lowers. And so that means that can't hold as much water in the clouds as the air pressure decreases. So all that water falls out as the clouds are forced up by the mountains. And then once the clouds get over, or the air mass gets over to the other side of the mountains, it has no more water. So it's bringing now dry air down the other side of the mountains. And so that tends to create dry areas like deserts. And that's what we call the rain shadow effect. So the side of the mountain that gets the most wind and rain is called the windward side, and the side of the mountain that tends to be the driest is called the leeward side. Also, proximity to large bodies of water can be really important. So if you're close to an ocean or a really huge lake, then you have a lot of local evaporation occurring, so that helps to form clouds, so that can help influence precipitation and temperature as well. And also water takes a lot more energy to change temperature than land does. Land changes temperature very easily. It doesn't take a whole lot of energy. So places near water will have temperatures that are more even, and places that are in the center of continents surrounded by land, their temperatures will change very drastically. And then also urbanization. So cities tend to make their own microclimate or their own tiny local climates. That we'll talk about more later when we talk about urbanization. But cities tend to have higher temperatures, higher precipitation, and lower winds because the buildings and things will block the winds. There are many, 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 many different kinds of climates on Earth, and we will look into those a bit more and discuss those a bit more when we talk about biomes. Those are our basics for atmosphere, the structure and function of the atmosphere, as well as the introduction to climate. So, we'll talk about this more in class, and in your textbook, the important sections to read are Chapter 3, Section 1, Chapter 7, Section 1, and Chapter 15, Section 1.